Hello! This is our final project video for MATLAB Engineering 6. My name is Neeraj.
My name's Lovleen.
My name's Ashna.
My name's David.
Let's get into it!
Alright, so let's first go over our core component app, and then we'll discuss our reach component, our final completed app. So let's run this first. It runs import map, which is here, and then you open it. The map displays. So when I hit the play button, the points will be plotted with a resolution circle around them. So as you can see, this is a 1 point and that's a resolution circle around it. Same with all the other points. This picture is showing 10 points that we collected. And now next we'll see our final reach component app.
All right, so let's take a tour of our app and kind of the physical visualization of how the app works. I'm in the MATLAB workspace right now, and I'm gonna hit the run button. So as you can see, after I've hit the run button, the app pops up. On the left-hand side, you can see your journey, and underneath the title, you can see the picture of the Davis map superimposed on a grid. Now, as soon as the app opens, the first thing that the user is going to do is go to the song selection drop-down menu. He's gonna click on any song that they may like. For example, I will choose Bollywood. After the song selection has been made, they're gonna click the play button. When you click the play button, the dynamic data will be plotted. As soon as the user's dynamic data has been finished plotting, you will get 3 statistics: total distance in miles, total time in minutes, and average speed in miles per hour. This was all calculated through the dynamic data that the user inputted at the very beginning. Additionally, on the very bottom right-hand corner of the app, you will see a calories burned section. For this section, the user must enter his or her weight in pounds and then press the calculate button. After pressing the calculate button, an output in the calories burned text box will show. As you can see, I have burned 148 calories in my journey. All right, so now we're going to talk about the core component of the project, specifically the mapping portion of the core component. The first step was to kind of go around the campus and collect 10 data points using our MATLAB mobile sensor data. Using this, we collected the latitude and longitude points for each of those 10 coordinates. Then we also used the G input function in order to calculate or collect the pixel X and pixel Y values of each of those 10 locations. We put all that data into 4 arrays in our MATLAB workspace: latitude, longitude, pixel X, and pixel Y. Once we constructed those 4 arrays, we then built a for loop to kind of use the differential between all those arrays. And what I mean by differential is we found all the non-repeat combinations of delta X, delta Y, latitude, and longitude. After these differentials were calculated, we then used this lines array to calculate the average latitude and longitude, as you can see in a secondary for loop. After this for loop was concluded, we then were able to get an average longitude ratio and an average latitude ratio, which basically means we were able to find the average longitude and latitude for 1 pixel on the map. After these values and averages were calculated, we then were able to construct a local function called GPS to pixel, as you can see over here. This function takes in a latitude or longitude, or an array of latitudes and longitudes, and maps them to their corresponding pixel X and pixel Y coordinates on the UC Davis map. Using this function, we were able to map any set of input points, latitude and longitude, into our output, which was our pixel degrees. That mapping process happened right over here.
Using the MU's 5x5 coordinate data of latitude and longitude to manually try to calculate the error. And the second method involved using the actual recorded error from the phone to plot the error sphere around each coordinate. So for the first method, we created a 3-dimensional grid, as you can see here, full of latitude and longitude data points in the 3rd dimension, with the 1st and 2nd dimension being corresponding to the grid. And then from there, we used a nested for loop inside the for loop to calculate the average distance and change for latitude and longitude that corresponded to each meter. And then we used that to find the actual error from those coordinates. But the second method we did use relied on finding the largest error, which we found while we were taking the data, which happened to be 2.5 meters. We then used a conversion factor of 111,111, which is the conversion factor from latitude degrees change into meters, and then we divided that by the average ratio of latitude and longitude.
Of this app, what we did is we assigned a callback function to the drop-down menu, and then what we did was that we assigned a value to the selection. So the way we did that was that we compared it to string value. So if the string value, for example, was Lady Gaga, it would then go to the if statement that says that the app selection was Lady Gaga with the string comparison, and then it would play that song accordingly by loading up the wave file into the program. And then it does that for every single selection that the user could possibly pick. So after the song selection has been made, then the gradient portion begins, and this is basically just plotting the points and changing from a blue to red color depending on the speed at which the person is traveling through the distance. So the way the gradient portion works is what we initially did was we translated the GPS latitude, longitude to pixel coordinates for the dynamic data, and we loaded up the dynamic data first and then called the function GPS to pixel in order to do that. And then what we did was that we assigned color values, red and blue, and we made those equal to each other so that we could change the values depending on the speed later on. And then in the for loop itself, what we made sure to do was to plot every other point so that we could clearly see the points as they're being plotted rather than being meshed together. So within the for loop itself, what we did was that if the dynamic speed, the next speed is greater than the current one, we increase the amount of red coloring and decrease the amount of blue coloring. We also made the pause time, we decreased the amount of pause time as well because it's a faster, it's plotting the points faster, so that we want to show that increase in speed at a quicker rate. And then we did an else if statement, basically the opposite of that, by decreasing the red value and then increasing the blue value, but increasing the pause time because it's a slower speed. So the points would be plotted at a slower time. Lastly, we just did called a scatter function, and scatter. This is basically just scattering the points, and then we filled them appropriately, and also increased the size of the plotted points, and then we just called the pause function accordingly.
Total distance, total time, and average speed. So let's first talk about total distance. We used our latitude and longitude data from our dynamic data to calculate the total distance. So basically, in a for loop, we found differences between one latitude point to another latitude point, and then we did the same thing for longitude. And then we found those differences, and then we converted them to miles. And then we could use that conversion factor and use Pythagorean theorem to find the distance between those 2 points. And we summed all of those differences together, and we found the total distance traveled. And for time calculation, we used the first timestamp that we had on the dynamic data and the last timestamp. We subtracted the last one from the first one, the first one from the last one, and then converted that to, dividing it by 60, we converted that to minutes. And then we manipulated it to show as a string on the display for our app. And then for average speed calculation, we used the average distance, and then we divided it by time and also divided by 60, so we could display miles per hour. All right, so now we're going to go over our calorie function. So basically, we took the user input for weight in pounds and converted that to kilograms using a conversion factor, and then we used that input to find calories. And to do that, we had 2 different components. One was finding the time they spent doing each activity. Since our dynamic data had a diverse range of activities, we had biking, walking, and traveling in a car. So we calculated times for each activity, and then we multiplied it by the constant that we found online for calorie calculation per activity. So for basically to find time, we used a for loop, and this for loop compares the speed. If the speed is higher than a certain speed, then we assigned a car value. If it's between certain 2 speeds, then we assigned a bike value. And if it was between the last 2 speeds, then it was running value. And if it was the lowest speed, then to a certain standard, and then we assigned it to walking value. And at the end of the loop, we combined all those values, and we found the total time that we spent doing each activity. And then we put it into the calorie calculation formula, which was basically multiplying it by the constant that we found online, by their weight in kilograms, which we converted earlier, and then multiplying it by the time. So we used all of that to do the calculation, and then we displayed the result using our edit field value for the user. Alright, let's talk about the challenges that we faced while completing this project. The first challenge that we faced was, despite having correct conversions from data points to pixels, we were still not able to plot. The solution was that we were missing an initial value for calibrating the map to our sensor data. After that change, the plotting aspect was perfectly functional. The second challenge was resolution. We had come up with a way to compute resolution that we did know worked, but we were not sure of the accuracy of our answer. So as advised by our TA, we matched our result to the horizontal accuracy column in our dynamic data. The results matched, so we proceeded on to using the dynamic data reported accuracy, and these were our two main challenges. And that was our project. Thank you for watching our video.